Hey folks, welcome back to section 8.4. Let's go ahead and do a few examples using vectors. All right, so we'll start with example number 1. And it says to find the magnitude, remember that's r, and the direction angle, that's theta, for the vector that ends at the coordinate negative 5, 4. Now, what are you given? Well, I'm given this right here, and this is, these are legs. And so what is it that I want? Well, I'm told that I want an R, and I told that I want a theta. And so let's go ahead here. I want R's and thetas. Now, one little clue, one little hint is anytime you're given legs, always, always, always go and draw a picture. So that's going to be the very first thing that we do here is let's draw a picture, and I've already got one started. So our legs, we went left 5 and up 4. And so let's go ahead and find our radius or our magnitude. So we'll use the Pythagorean theorem here. So my radius is going to be 4 squared plus negative 5 quantity squared, square root. So then this will be 16 plus 25 in the square root, which is the square root of 41. So the magnitude of vector u is going to be the square root of 41. Now, this is not a unit circle type of triangle, so I'm not going to worry too much about trying to use the unit circle values on this. I'm just going to go back and use tangent because tangent allows me to use the two legs that I was given. So my tangent of my theta is going to be opposite over adjacent, 4 over negative 5. What finds angles? Well, inverses find angles. So we go ahead, and since this is not a unit circle value, we'll type it into the calculator, and we'll get negative 38 degrees. Now, let me ask you something. When you look at your picture, you should always compare to your answer and ask yourself, are these the same thing? Do they match up? Are they in the same quadrant? Well, no. Negative 38 degrees is a fourth quadrant angle, and my picture is supposed to be a second quadrant angle. So remember that tangent inverse has a restriction of only using the right side of the circle. That was back in chapter 7, I think. And so we have to adapt. So because of the fact that I was thrown down here, I need to get halfway across the circle to my proper quadrant. So we're just simply going to add 180 to our current answer, and that will be 141.3402. This is in the second quadrant, and this makes more sense. All right, now let's jump down to example number 2. So let's take a look at the directions. Vector v has a magnitude, remember this is the same thing as r, of 14.5 and a direction angle, this is theta, of 220 degrees. Find the horizontal and the vertical components. So what have you been given? Well, we've been given r and theta. What is it that we're trying to find? We're trying to find the horizontal and vertical components. Oh yeah, those are the legs. Okay, so we want to find the legs. So what we're going to do, anytime you have r's and thetas and you want legs, we want to go back up here and use those handy dandy little equations that we've already found. If I want leg A, I'll do radius times cosine of theta. If I want leg B, radius times the sine of theta. So let's go ahead and set up our two equations. So my leg A will give me r cosine theta. My leg B is r sine theta. And to get my A leg, my horizontal leg, we will just simply substitute my magnitude and my direction angle. Throw that into the calculator because this is not a unit circle value. Folks, when it is a unit circle value, you will be expected to use exact answers. So just be aware of that. Now, this doesn't say anything at all about rounding, but I'm going to guess that according to significant figures, we're probably going to go to one place, I'm going to guess. So we'll say negative 11.1. The nice thing about my lab is that it will always tell you how to round. So you won't have to have any guesswork on that. Um, uh, so to find side B, our vertical component, again, we'll go ahead and substitute our r's and our thetas and throw that into the calculator. And then when rounding, negative 9.3 for the vertical component, for the vertical leg. All right, let's look at example number 3. Now, example number 3 says to write the vector like this. Okay, so just be aware that sometimes you're only asked for the separate pieces, the separate legs, but here you're actually asked to write it in a specific form. Now, notice all 3 pieces of these examples, you're given a magnitude of a certain amount and a direction angle, all 3. So what is given here on all 3 of these, the r and the theta is given. And what is it that we're trying to find? Well, we're trying to find this, which is my legs. All right, so ultimately, anytime you want legs and you have r's and thetas, we can use our handy dandy formulas for those. All right, so the formula for finding A is r cosine theta. So let's go ahead and substitute 8 times the cosine of 135. Folks, this is on the unit circle. So once again, anytime you're working on the unit circle, you're going to need to give exact answers. So the cosine of 135 degrees is going to be negative root 2 over 2. And when we multiply, this is going to be negative 4 root 2. To get leg B, we will do r times the sine of theta, which is going to be 8 times the sine of 135, which is going to be 8 times root 2 over 2, which is 4 root 2. Now, I would love to tell you you're finished, but remember you were supposed to write this in a specific form. And so that form is going to be using those pointy brackets with my legs inside. All right, the second piece here, the second example, I have a magnitude of 4, direction angle of 270. So we're going to do the exact same thing. So our leg A is going to be r times the cosine of theta, which is going to be 0. And you say, well, how in the world did you get that? Because you didn't really show your work here. And just think of it as this is going to be 4 times the cosine of 270. And 270 is down here at the bottom. The cosine of 270 is 0 times 4 is 0. To get my leg B, we'll do r times the sine of theta. So this is going to be r times negative 1 or 4 times negative 1, which is going to be negative 4. And how do I write that then? We will write that as 0, negative 4. The other thing, too, is I really didn't even need these formulas here. The minute I can see a picture of where 270 is and that I have a radius of 4, I know that this is the coordinate 0, negative 4. All right, the last of these 3 is not a unit circle value, so we'll need our calculators for this one, and it will not be an exact form. So we have A is equal to r cosine theta, B is equal to r sine theta. For our cosine theta, that'll be 10 times the cosine of 340. Throw that into the calculator, we get 9.3 something or other. And when we plug in for the second one, we have 10 times the sine of 340. Throw it into the calculator, and that's negative 3.4 something. When we write it in the proper form, here I included more decimals. We've got the following vector of this 9.3969, comma, negative 3.4202. Again, just pay attention to what my lab says to do as far as rounding is concerned, and that way you don't have to decide whether or not you're supposed to use significant figures or you're not. All right, I'm going to stop the video here, and we will come back and talk about some operations that we can do on vectors.